Okay, so tomorrow on your test, 12 to 14 questions, something like that. You guys have to know how to do this stuff from 1.8. Solving absolute value equations and inequalities, okay? You probably have one of those. You're going to have a couple graphs where you are going to have to tell me all of the stuff, the domain, the range, the intervals of increase, decrease, constant, stuff like that. I want to do 3 and 4 with you guys. Everything is posted on Canvas. Everything's all pretty and worked out, but I want to do 3 and 4 with you guys. First of all, when you have a question that says f of -4 or f of 2, what does that mean? What is that telling you to do? To find the y value at whatever x value I give you. So at x is -4, what is the y value? 1, 2, 3, 4. So you guys would literally write 5. That's not a hard question if you understand what they're asking. If you don't understand what it's asking, you're going to have no idea how to answer it. So what is f of 2? What is the y value? There you go, 3. Does anybody have any questions on those two? All right, super basic. But again, if you don't know what you're doing, that's difficult. Yes, sir?
Why wouldn't it be for that one, if f is 2, wouldn't it be 3 and, what's it called, and 5? Or is it because it's not included?
It's only at where x is 2, what is the y value? Right, that's the only thing that falls on it. This is not included here.
All right.
It wouldn't be a function if it was included. Then it wouldn't be considered a function. All right, let's talk about domain and range and stuff for this one. These two are a little more difficult. That's why I'm doing these with you. The other ones are very similar to the ones we've done before, so you can watch videos on that and look at the notes. But your domain values, guys, how do we read domain? From where to where? Left to right. So look at this. Think about it this way. The furthest left that I go is right there, correct? What is that number? -4. So your domain is -4. It includes it, right? Now let's see where our domain values, where our x values are being used. All along here, there's x values being used, right? On my red line. Okay, still being used, still being used, still being used. Still being used, right? Still being used. To right here. Are there any gaps? Is there any place that I just went left to right in the blue where there's no x values being used on this graph? No. So you don't have any breaks in your domain here. Your domain is just -4 to what?
4.
+4. And it includes both of them, correct? Okay. Let's do the same thing then with the range. Let's do the same thing. Highlight, look. If you need to turn your papers sideways or whatever you need to do, but use a different color. What is the lowest value that I use here? 0, okay? So at any point, are y values being used on any part of my red line? That means your range exists there. So here, yeah, we're being used, yes, yes. There's a break right here, correct? Yeah. But it's still being used over here. Same y value, still being used, all the way up to what? 5. Now there's an open dot on one side and a closed dot on the other. It's still included. A closed dot overrides an open dot. So your range here would be 0 to 5, and it includes it. Doesn't include on this side, but it does include it there. Yeah?
Why is it 0 in brackets?
Because it includes 0. Do you see how the line exists right there at 0?
Yeah.
That's why.
It's always in the brackets.
If it goes through that point, yeah. Mm-hmm. Yes, ma'am.
So for the domain, you use the x, and for the range, you use the y.
Mm-hmm. All right, so our intervals of increase, decrease, and constant. What axis do I look at? The x. Okay, this is really simple concept if you know where to look. Don't look at the y. I don't care how high and low this thing goes. I picture this, I draw it. What is my function doing on this yellow area where I just drew? It's going which direction? It's decreasing from where on the x-axis to where on the x-axis is it decreasing? From -4 to 0. We always use parentheses on increase, decrease, constant. Always. You can never increase and decrease at the same time. So as we're moving left to right, we're still looking left to right. What does my function do here? It goes up. It increases. So from where on the x-axis to where on the x-axis is it going up? Good, Bella. 0 to 2. And then what happens again?
Decrease.
It decreases again. It's going down from where to where. It's decreasing from 2 to 4. Do you guys see that? Yes,
Would you use the union, like in the?
for domain and range. You could use it here too if you wanted to. I wouldn't mark it wrong. Yeah.
You always use parentheses when you're doing the decrease.
Yes. Increase, decrease, and constant is always parenthesis.
Well, you said we put the union between the domain and the range.
Yes. Not here. When there is one, like in a second when there's a break.
Use brackets for the first question.
For what?
In the pencil.
For the constant here?
No,
On number 1.
we didn't do it. It's on the answer.
Okay, I just need to change them to,
Even if it has close to it.
yeah. For increase, decrease, constant, yeah. All right, this one is more difficult, guys. You will probably see something like this. This is why I put it on here. This is why I'm choosing to go over it with you. You have to be able to visualize things. So bring in colored pencils if you need to or something. We're going to talk about the domain. Domain are my x values from left to right. So remember, over here is negative infinity. Over here is positive infinity. This function is just going to keep on going this way forever, right? So let's talk about the values on the x-axis that are being used. Everything along here is being used. So then all of a sudden what happens? It stops. So what is my first piece of domain? Negative infinity to what? To negative 3 with a what? Parenthesis. Now, what do you notice? If I pick up my domain again, where do my x values start again? They start at negative 2 and they go to what? To 1. They go to from negative 2 to positive 1. Why did I use brackets there? Because they're closed circles. Now look, from left to right, where do your x values start again? To what? 3 to 5. Includes 3, doesn't include 5. This is where we use a union. You use a union, guys, when there is a gap, when there's a break. So it's here, and there's another gap here. There's a break. Do you guys see why there is a noticeable gap? Because there are absolutely no values being used on the x-axis in those yellow areas. Everybody see that? All right, so now, God bless. All right, we read range from bottom to top, right? So let's start. What is the lowest value that I have here? Well, my iPad's stuck. Okay, so negative 3, right? You guys agree with me right here? Okay, so there's values being used. Oh, no more. But if I keep going, are there values over there being used? Okay, all the way up to where? 0. So your range is from negative 3 to 0. Includes both of them, yeah? Okay. And then what do you notice? There's a huge... All right, so look, what do you guys notice here? There's a huge what? There are no values at all being used in that yellow area. But I do see values being used again. What value is being used again? 5. Is anything above y equals 5 being used? No. Is anything below y equals 5 being used? No. Just 5. That's why this 5 is all by itself in a bracket. Because it's included right there. That's where that value is included. It's not included here at that x value, but it is included right there at 5. What's up?
How come it wouldn't be like, since negative 3 is the one all the way on the bottom, wouldn't it be negative 3 and then 5?
Actually, you know what? Hold on. Say it again.
Since the range, the one on the bottom is negative 3 and the top is 5. Why is it negative 3 to 0?
Because there's no values here on the y that are used. So you can't include it in the range. That's where the gap is. But when you have a constant, guys, when you have a horizontal constant like that, your range is always going to have something that's just one number by itself because there's nothing above it, there's nothing below it. It's just right there equal to that y equals value. But sometimes that's hard to see, so I want you guys to see that. You got it? All right, let's do some piecewise stuff. Piecewise, I want to do number 6 because I had a lot of people ask questions about that last period. All right, there's 3 different equations here. 3 different equations tells us we have 3 different graphs. What do you notice about the first one? It says y equals negative x squared plus 3. It's a parabola, good. Now, if you guys are going to do a table of values for this, right? Somebody last period, they did this awesome. They did a table of values, and they just kept getting the wrong answer. And I need to show you guys why. All right, guys, when you plug in negative 2 here, this says negative 2 squared plus 3. What is negative 2 squared? 4 times negative 1. So negative 4 plus 3 is negative 4 plus 3 is negative 1. Now I'm going to plug in negative 1. So I have negative 1 squared plus 3. What is negative 1 squared? 1. But then there's a negative in front of it, so it becomes negative 1. What's negative 1 plus 3? 2. 0. 0 squared is? Plus 3? 3. All right, now watch, guys. This is negative 1 squared plus 3. You square the number first. What is 1 squared? 1. So this is 1. Then you put that negative with it. So negative 1 plus 3 is 2. Here I have negative. You have negative 2 squared plus 3. So 2 squared is 4. This becomes negative 4 plus 3, which is negative 1. That is not 7. Really important that you guys see that. That negative is on the outside. That means square that number first and then apply the negative to it. So your parabola looks something like this. Negative 2, negative 1. Negative 1, 2. 0, 3. And then this way. If you guys knew your transformations, you knew that this would be a parabola because it's squared. You knew that it would reflect over the x-axis. It would flip over. And you would know that it would move up 3 on the y-intercept. That's why it's helpful to know those things. So if we connect our dots, nice and pretty, and then we look at our boundary line. This is where our piecewise comes in. We look at the boundary line. I want all the places that are what? Less than or equal to negative 1. Here is negative 1. On the x-axis, where are the values less than or equal to negative 1? To the left of that or to the right? To the left, over here. So we want to keep that, and what do we do with everything else? You erase it. Good. And the last thing you need to look at after you do your erasing and stuff is say, oh, wait a second, what kind of a dot should I have there? Close. Why is it closed? Because it's or equal to. Good. Your next one says it should be 2/3, right? We changed it yesterday. 2/3 minus 2. You guys don't have to do much work for this other than recognizing that your slope is 2/3 and your intercept is at negative 2. It's an upward sloping line because it's positive. So I'm going to go to negative 2 and it's 2/3. So up 2/3, down 2/3. Up 2/3. You have like a general idea of what your line looks like. And then where am I looking here? What's my boundary line? Negative 1 and 3. I want in between negative 1 and 3. If x is in between, then where do you think I want to keep the line? The in-between part. So I want to keep the stuff that's in here. And what do I do with everything else? You erase it. Good. Guys, I'm not going to have 27 extra erasers. I don't have any extra pencils. I had like 1,000 pencils when school started, and now I have like 2. Look at your dots. What kind of dots should you have on both of those? Open. So make sure I know, ooh, this is an open dot. Look, Mrs. Meadows, this is open. This is open. Do whatever you need to do to tell me that. Erase, whatever, yeah.
Is there gonna be like a graph like that given, or we're gonna have to like make our own graph?
You're going to have to make your own.
Like the lines?
Oh, no. I have the coordinate plane on there for you. Oh yeah, that would be crazy for me to try and grade. All right, where is y equals -4? It's a horizontal line. Good, Jack. Good, Marissa. At -4. 1, 2, 3, 4. It's right here. These are the easy ones, guys. Where do I want to keep the stuff? Where do I want to erase the stuff? Greater than or equal to 3. So I'm going to go right here to 3. 1, 2, 3. Look. I'm going to keep everything over here and do what? Erase. Erase. Sometimes I wish you guys could do these on Notability because it does make it a little easier for you. But you will have to graph tomorrow. So make sure you know how to do that. All right, let's get on down here. We need to talk about domain. We're going to talk about domain and what makes something a function, to find a function. Your domain of any equation that you have is all real numbers, except for 3 things. Number 7 breaks the first rule. What's the first rule? There's a variable in the denominator. All right, this is a problem that there's a variable in the denominator. What do we have to do? We have to figure out what? What do we have to figure out?
What you can't plug in there.
Right, what you can't plug in. How would I attempt to do that, guys?
Set it not equal to 0.
Set what not equal to 0?
The bottom equation.
The denominator. Good. What you end up doing is what? What do you end up doing here? Factoring. You're going to end up factoring. All right, how do we factor this? 9 times -2 is -18. What are the factors of -18? That multiply to give me -18, but add to give me 7. X plus 9, x minus 2. What do I do with my a term? Divide both. So I get x plus 1, and I get 9x minus 2. So I go ahead and I solve both of these. I get x equals -1, and I get x equals positive 2/9. Yeah? All right, what does that mean? Jeffrey, can you tell me what that means? Gus, can you tell me?
No, when you put it on the line, it doesn't equal.
Okay, when you put it on a line. Good, that's a good thought. Let's graph it. You guys give yourself a little bit, excuse me, a little bit of a visual representation. It means it cannot equal. So if I was going to graph this, what kind of a circle would I have at -1 and positive 2/9? Open, because it does not include. So what you're telling yourself is you can use everything over here, everything in here, and everything over here. The only things you can't use are -1 and positive 2/9. Sometimes, guys, it's easier for you to see how to write your interval notation if you write it out like this on a graph so you can see it. What would your domain be for this question? -∞ to, perfect, -1. Then what? -1 to 2/9. Then what? 2/9 to infinity. And notice what I put on the 2/9 and the -1. Parentheses or brackets? Parentheses, because it does not include. But anytime you have a variable in the denominator, 95% of the time it's going to be a factoring question. Yes, sir.
Wait, why does it not include like the?
Because if you plugged in -1 here and here, when you evaluated it, it would become 0.
Okay.
Same thing with 2/9.
So if it becomes 0, then it's open circle.
Right, because that would make your fraction undefined. All right, so if I scoot along over here, guys, what's the problem? There's a square root. There's a variable underneath the square root. You take the expression, not the whole equation. You take that expression and you set it greater than or equal to 0. You can take the square root of 0, that's fine. So if I was going to solve this, we square both sides, right? 6x plus 5 greater than or equal to 0. Subtract 5 from both sides. 6x is greater than or equal to -5. Divide by 6. So I get x is greater than or equal to -5, 6. You have to tell me the domain in interval notation. It might be easy to do this. Here is -5, 6. Here is 0. Does it include -5, 6? Yes. Which way do I color?
Greater.
So your domain is from where to where?
-5, 6.
negative 5, 6 to infinity. Mhm.
Did you add 7? Because 7 at the end of it.
No, you only the expression itself, not the whole equation. Good question. Very good question. Yeah, that's why I circled it. You only set the radical greater than or equal to, not the whole equation. So here's a combo. There's two problems here. What are the two problems? It's a variable where? In the denominator, and it's underneath the square root. So in this case, you take the expression and you set it what? Greater than 0. Cannot be equal to, because what happens if it's equal to? Your function becomes undefined. So we're going to square both sides. Negative 2x plus 5 greater than 0. Subtract 5, yeah? Negative 2x greater than negative 5. Divide by negative 2. Guys, what happens when you divide by a negative? Your inequality sign flips. So if I was going to graph this, here's 0, here's 5 over 2. What kind of a dot do I have at 5 over 2? It's open, and which way do I color? To the left. So my domain would be negative infinity to 5 over 2, but it's a parenthesis because it does not include when he gets back. All right, what's my answer here? What's my domain? Negative infinity to positive infinity. Why is that? We're not breaking any rules. I don't have anything in a no variable in a denominator, no variable underneath the square root, no square root in a denominator. We're good to go. All right, ones I want to look at. We'll do these, then we're done. I'll let you guys rest. Does the function define y, or does the equation define y as a function of x? Why or why not? The why or why not is an important part, guys. What is the only thing that matters when you're looking at these equations? The y. Look at the y. Y is all that matters. There's two things y cannot be. Okay, so what should I do here? Is this a yes or a no?
No.
The answer is no, and you have to tell me why. Because y is raised to what? Good, an even power. The two rules are y cannot be raised to an even power, and y cannot where? Be inside absolute value. The two rules are y cannot be raised to an even power, and y cannot be an absolute value. Does it break either of those rules? So yes, this is a function. No, 3's odd.
Oh,
Like 2, 4, 6. You're just thinking power. It's okay. All right, look, circle the y. The y is the only thing that matters. Is 14 a function? Yes or no?
No.
Why not? Because y is an absolute value. Because y is in absolute value. Good. What about 13? Look at y. Problem? Nope, no problem. So yes, this is a function. Good. All right, lastly, guys, we're going to talk about evaluating piecewise. I'm going to give you a set of piecewise equations. And I'm going to say, evaluate at the given value. Well, what does that mean? This is the x value that I'm giving you, 3 over 2. 3 over 2 is 1 half, 1 and 1 half, right? Where does 3 over 2 fall? Is 3 over 2 less than negative 3? Is 3 over 2 in between negative 2 and 3?
Yes.
Yes. So you would evaluate using that equation, 1 half x plus 4. So I'm going to say 1 half times 3 over 2 plus 4. What's 1 half times 3 over 2? 3 over 4, good. Plus 4, change 4 to fourths. Becomes what? 16 fourths. So what's your answer? 19 fourths. So when you have 3 over 2, go ahead, Andre. When you have 3 over 2 as your x value, when you evaluate using the piecewise function, you plug that into whichever piece it falls into, and you get your y value. Same thing over here. 6. Well, where does 6 fall? Which equation does 6 fall into? The last one, 3x minus 2, because it's greater than 3. Good. So I have 3x minus 2. So I'm going to say 3 times 6 minus 2. What's 3 times 6? 18, and 18 minus 2 is? So f of 6 is 16. You'll have a question like that, for sure. All right, so make sure you guys are going over all the rules, the domain stuff. Make sure you understand how to graph a line. Make sure we understand when and why you can have x in the denominator or can't have x in the denominator or what it's going to do to the domain, all that good stuff. All right, sound good?